In this section, we state the channel coding theorem for the continuous memoryless channel. An NM code for a continuous memoryless channel with input constraint kappa p is defined by an encoding function e from the set consisting of 1 to up to m to r to the power n, and a decoding function g from r to the power n to the set consisting of 1 to up to m. Here, the set consisting of 1 to up to m is called the message set W. The code words are e of 1, e of 2, up to e of m, where e of w, the wth code word, has components x1 of w, x2 of w, up to xn of w. The set of all code words is called the code book. Moreover, 1 over n summation I from 1 up to n, kappa of xi of w, is less than or equal to p for all w between 1 and m. That is, each code word satisfies the input constraint. Here are some assumptions and notations. W is randomly chosen from the message set W, so the entropy of W is equal to log of m. We use bold capital X to denote the random sequence inputs to the channel, with components x1, x2 up to xn, and bold capital Y to denote the random sequence output from the channel, with components y1, y2 up to yn. Thus, x is equal to e of w. That is, the input sequence to the channel is equal to the code word corresponding to the chosen message. Let w hat equals g of y be the estimate on the message w by the decoder. The relations between these random variables are illustrated by the block diagram as shown. Now we define the error probabilities. For all w between 1 and m, let lambda w be the probability that w hat is not equal to w, conditioning on w is equal to w. That is, lambda w is the conditional probability of error given that the message is w. The integral gives the expression for lambda w. The maximal probability of error of an NM code is defined as lambda max, which is equal to the maximum of lambda w over all w. The average probability of error of an NM code is defined as PE, which is equal to the probability that w hat is not equal to w. A rate R is asymptotically achievable for a continuous memoryless channel if for any epsilon greater than 0, there exists for a sufficiently large n an NM code such that 1 over n times log m is greater than r minus epsilon, and lambda max is less than epsilon. Theorem 11.14, the channel coding theorem, states that a rate R is achievable for a continuous memoryless channel with input constraint kappa p if and only if R is less than or equal to C of P, the capacity of the channel.